Welcome to Raw Machines, a journey into the world's most remarkable production processes. In this episode, we visit a traditional copper hammering workshop in Mönchengladbach, where the craft heritage of the Johannes Jansen family has been preserved across generations. From flat sheets of tombac to finely formed objects, every hammer blow and annealing cycle reveals a precise and resilient technical system, a testament to the enduring vitality of traditional craftsmanship. Let us begin. The copper works found in churches throughout Mönchengladbach, most notably the crucifixion scene in the Gnadigen Parish Church and the baptismal font in Rheinland, testify to the high level of traditional copper repoussé craftsmanship associated with the workshop of Johannes Jansen. By the late 19th century, industrialization led to the decline of copper hammering, and the Johannes Jansen workshop became one of the last establishments in the Rhineland to preserve this artisanal tradition. The primary materials used in copper hammering are copper and its alloys, among them tombac, a copper-rich alloy containing approximately 90% copper, is highly ductile and capable of withstanding significant deformation, making it particularly suitable for repoussé and hammering techniques. The manufacturing process begins with flat sheets of tombac, cut into blanks according to predefined shapes. This cutting stage is of decisive importance as it determines from the outset the proportions of the form and the amount of material reserve required for subsequent shaping. Proper preparation of the blank is a fundamental prerequisite for controlled stretching and shrinking of the metal during the following forming stages. In the workshop of Johannes Jansen, the forge and bellows play a crucial role in the thermal treatment of the metal. The furnace is not used for shaping directly, but for annealing, restoring the metal to the soft condition required for hammering. Shaping with the hammer is carried out only after the metal has cooled, in keeping with the specific nature of copper hammering as a cold working craft, distinct from blacksmithing, which works hot meta. During the hammering process, the continuous impact of the hammer causes the metal to work harden, gradually becoming stiffer and less ductile. Once the material is no longer suitable for further shaping, the metal sheet is returned to the furnace for annealing, restoring its softness and allowing the work to continue. After annealing, the metal is left to cool naturally in the workshop, avoiding rapid quenching in water. This cycle is repeated many times until the desired form gradually emerges. Johannes Jansen began his apprenticeship as a copper hammerer in 1953 and joined his father's workshop after completing his training in 1958. From the late 1970s onward, as traditional copper hammering steadily declined, the Jansen family workshop focused primarily on repair work and small commissions. During the manufacturing process, after each annealing cycle, the metal blank typically becomes covered with soot and forge scale. The cleaning of the workpieces is carried out by Gerd Jansen, the son of Johannes Jansen. First, coarse residues are removed mechanically. The metal is then taken into the workshop yard and pickled in hydrochloric acid to eliminate oxide layers. Once rinsed clean, the blank is dried with sawdust in preparation for surface treatment. Building on this, Johannes Jansen continues the refinement of the blank by sanding to brighten the metal, followed by filing to remove burrs and smooth the edges. These operations stabilize both surface and form, creating the necessary conditions for the subsequent shaping stages. Once the metal blank has been cleaned and surface treated, the forming process begins. Johannes Jansen shapes the metal according to technical drawings, a method requiring a high degree of precision and differing from the customary practice of copper hammerers, who traditionally rely largely on visual estimation. Forming is based on two fundamental techniques: stretching and shrinking. Stretching thins the metal and expands the surface, while shrinking compresses the material, increasing its thickness and raising the walls. Hammering begins on a wooden forming block using a ball-peen hammer. First, the edge of the metal sheet is worked to prevent wrinkling and distortion. The metal is then hammered from the center outward in concentric circles. The hammer blows are placed densely and evenly, close together across the surface, establishing a steady working rhythm. Raising a vessel from a flat metal sheet is a time-consuming process. For a container, such as the one shown in the film, the craftsman requires an average of 4 to 6 hours of labor. Once the basic form has been established, Johannes Jansen uses a wooden mallet to adjust the curvature, ensuring that the vessel walls become more uniform and stable. While Johannes Jansen continues raising the body of the box, Gerd Jansen works on a copper emblem plate. First, the edge of the metal sheet is gently folded with a wooden mallet to stabilize its shape. Molten pitch is then heated with a propane torch and poured evenly over the surface of the copper, forming a resilient support for repoussé and chasing. Before the advent of blowtorches, the pitch had to be melted directly on the forge. The pitch layer must be applied uniformly, as only a consistent backing allows the metal surface to be worked without producing unwanted irregularities. This pitch-based technique does not originate from the traditional production of household wares by copper hammerers, but became widespread when workshops shifted toward the manufacture of ornamental and artistic objects, such as signboards and heraldic plaques. During the process, as the metal gradually hardens and emits a characteristic sound, this indicates work hardening and the need for re-annealing. In parallel with the shaping work, Gerd Jansen regularly cleans the tools, sanding the hammers to remove small metal particles that could otherwise leave marks on the surface during hammering.
So, Vater, die ist fertig gesäuert, die kannst du wieder drehen. Ja?
Alongside the ornamental work, the shaping of the box body continues using the shrinking technique on a specialized anvil. To raise the walls and achieve the exact dimensions specified in the drawing, Johannes Jansen clamps a long, narrow anvil into a vise, known as an easel, designed specifically for shrinking operations. Before beginning, the rim of the object is reset with a wooden mallet to stabilize the form and prevent wrinkling during further work. Measurements are transferred directly from the drawing onto the object, and the positions of the hammer blows are marked. Johannes then uses the rear edge of the hammer to carry out the shrinking process. At this stage, the metal is not stretched but compressed, forcing material toward the rim, thickening it, and gradually raising the wall, in contrast to the stretching technique. After each shrinking cycle, the object is returned for annealing to restore the metal's ductility, allowing subsequent hammering to proceed without cracking or distortion. Soldering is an indispensable technique in copper hammering, particularly when metal components must be joined seamlessly. During preparation, Gerd Jansen applies flux to the edge of the copper sheet. The activating agent used is zinc chloride, which cleans the surface and facilitates the soldering process. At the same time, the traditional soldering iron is heated directly in the fire until it reaches working temperature. The temperature of the soldering iron is not measured with instruments, but tested using the so-called cheek test, Wangen probe, in which the craftsman briefly brings the hot iron close to the cheek to sense its heat. Once the correct temperature is reached, the tip of the iron is cleaned and activated with ammonium chloride stone, ensuring consistent heat transfer and proper adhesion of the solder. The choice of solder depends on the intended use of the object. Hard soldering with brass or silver may be employed. For domestic vessels, the interior surface is commonly tin-lined to meet hygiene and safety requirements. From the 19th century onward, metal edge-bending machines began to be introduced into workshops as auxiliary tools, allowing folds to be formed more evenly and precisely than by purely manual methods. In practice, the edge of the copper sheet is first bent by machine, after which the folds are refined with a wooden mallet to achieve the required tightness and structural stability. When forming and assembling pipes, a gauge bar is clamped firmly in a vise to maintain the correct cross-section. The two ends of the pipe are then hammered closed to lock the seam and secure the shape. These operations make it possible to produce durable copper pipes suitable for installation in water supply systems, gutters, and roofing. Long-standing and practical applications of the copper hammerer's trade. To secure the seam and prevent the edges from slipping, Johannes Jansen tightens both ends of the pipe using a folding hammer. Gerd Jansen then forms the edge and creates the falls, a technical folded seam used to join and seal metal. The pipe edge is shaped with a falls hammer, drawn back to standard dimensions using a falls iron, and then flattened to stabilize the form. Because the pipe is to be sealed at one end to serve as a watertight liner for a flower vessel, the base plate is cut and fitted precisely. The rim at the end of the pipe is adjusted with a planishing hammer on a polishing stake to achieve high accuracy. The bottom seam is then closed on a folding stake, forming a double bottom falls. Finally, on a locking hook, the seam is tightened one last time, completing a sealed and structurally stable base for the vessel. Once the false seam has been closed, the pipe is still not fully watertight and must be soldered. Gerd Jansen first applies a thin layer of clay to the outside of the seam to prevent molten tin from flowing outward. Small pieces of tin are then placed inside the pipe, after which the entire piece is set into the forge, allowing the solder to melt and flow evenly along the falls, fully sealing the joint. This method of sealing was once widely used in repair work, such as patching small holes, cracks, or broken handles on pots and other metal household vessels. After soldering, the copper pipe is polished on the surface. The watertight flower vase liner is thus completed, marking the conclusion of the fabrication of this functional component. After completing the main forming stages, Gerd Jansen returns to work on the emblem plate. The design, drawn on paper, is glued onto the metal sheet in mirror image, so that when chased from the reverse, the relief appears correctly oriented on the front. Following the marked lines, he uses various chasing punches to strike each contour, selecting tools according to the desired thickness and depth, in order to produce a clearly defined relief on the display surface. In parallel, Johannes Jansen continues raising the walls of the object on a domed anvil. The starting point is marked with a line, from which the wall is gradually drawn up in circular passes until the required height is reached. This process demands precise control of hammer force to ensure that the walls are raised evenly and remain structurally stable. Gerd Jansen continues working on the creation of his own workshop emblem. Using a pair of compasses, he precisely defines the outer limits of the motif, consisting of a hammer, initials, and a date, establishing the framework for the repoussé and chasing work. First, the contours are redrawn with a liner punch to create clear boundaries for the ornament. On this basis, the larger areas of the design are gradually raised using broader punches, allowing the relief to emerge evenly and distinctly on the display surface. This stage requires strict control of line and form, as each blow directly affects the final shape of the emblem. The completion of the motif thus clearly demonstrates the high degree of specialization inherent in repoussé and chasing techniques, which play a central role in the workshop's emblematic and symbolic works. In the finishing stage, Johannes Jansen carries out the final refinement of the tomback box. First, the dimensions of the base are determined with compasses and transferred onto the workpiece. As scribed lines are easily lost during hammering, measuring and marking must be repeated several times to ensure accuracy. To flatten and stabilize the base, Johannes mounts a specialized flat anvil. Using a highly polished planishing hammer, he works the base evenly to take down the surface, ensuring it is flat and free of hammer marks. This operation requires extremely delicate control of force, as even minor deviations directly affect the quality of the finish in. The final fine adjustment stage, Johannes Jansen continues working on the forming stake. Here, the foot of the box is attached and its shape corrected. Although a minor operation, this step requires precise tactile judgment to ensure the balance and stability of the entire object. In parallel, Gerd Jansen removes the emblem plate from the pitch backing. The pitch is heated in a tray until it softens, after which the emblem is released and the remaining material is thoroughly cleaned from the surface. Once the pitch is removed, the chased relief emerges clearly, marking the completion of the repoussé and chasing work and preparing the piece for subsequent surface treatments. To remove any remaining traces of pitch, Gerd Jansen returns the emblem plate to the forge and heats it until the pitch burns off completely. Such procedures illustrate the health risks traditionally associated with the copper hammerer's trade, in which craftsmen are regularly exposed to furnaces, acids, and fine metal particles produced during annealing and heating. Meanwhile, Johannes Jansen completes the box body on a domed anvil. He first uses a planishing hammer to flatten the surface, then finishes the entire vessel with a teller hammer, working evenly in circular passes from the base up to the rim, producing a stable and uniformly refined surface. After the soldering and surface finishing stages, soldering and tinning materials must be prepared separately. At this point, Gerd Jansen casts tin bars and produces powdered tin, strozin, for use in joining and tinning operations. First, small pieces of tin are melted in a crucible. The tin-lead alloy commonly used for soldering contains approximately 40% lead, whereas strozin requires a very high tin content, typically 90% or more. The molten metal is skimmed to remove ash and impurities, then poured into molds to cast tin bars. Once cooled, these bars can be used directly or stored as raw material. To produce strozin, a portion of the tin bars is remelted at around 300 degrees Celsius. As the metal begins to cool, it is stirred to form a granular structure, then poured into a felt cap, where the fragments collide and break into small particles. Finally, the mixture is sieved to obtain fine powdered tin, ready for tinning and soldering processes. After the forming and soldering stages are completed, vessels intended for storage or contact with food must be tin-lined on the interior. This is a mandatory finishing step, intended to prevent the formation of soluble copper compounds that could be harmful during use. The tinning process begins when Gerd Jansen brushes flux onto the interior surface to activate the metal. On this base, strozin is evenly sprinkled to form the initial coating material. Under the flame of a blowtorch, the tin melts and spreads in response to the movement of the brush, with additional flux applied as needed to ensure continuous and uniform adhesion. The technical requirement of this operation is that the entire interior surface be fully covered with tin, leaving no exposed copper. Once the tin layer has leveled and stabilized, excess tin is wiped away, completing the tinning process and ensuring the product's safe use.
Gerd?
While the tinning work is carried out by Gerd Jansen, Johannes Jansen inspects and fine-tunes the box body on a domed anvil. Minor irregularities along the rim are hammered and ground back in preparation for fitting the lid. A brass sheet previously cut by Gerd is then raised by Johannes into the box lid, shaped on a girdleisen to achieve an exact fit, and carefully refined along the edge. In parallel, Gerd demonstrates the technique of forming a decorative sphere from a copper sheet. The sphere is raised to an approximate shape and then filled with molten lead to stabilize it during working. A metal wire is inserted while the lead is still liquid, serving as a temporary handle. Once the lead has solidified, the surface of the sphere is cleaned. The opening is gradually closed with a peen hammer, and the form is rounded using a teller hammer. Finally, the handle wire is removed, the lead core is reheated and poured out, completing the hollow decorative element. The choice of a bright copper alloy for the lid and sphere, contrasting with the darker tone of the tombak box body, creates a distinct visual effect in the finished object. In the final stage, Gerd Jansen carries out the last refinements on the emblem plate. The object is returned to the tray with the display side facing upward, and its edges and contours are adjusted one final time to achieve sharpness and balance. The surface is then polished with pomade, producing an even metallic sheen and completing the object's appearance. These finishing operations bring to a close the entire sequence of manual processes. From material preparation, forming, soldering, and tinning, to repoussé, chasing, and polishing. In the hands of Johannes Jansen and Gerd Jansen, copper hammering emerges not merely as the production of a finished object, but as a coherent technical system grounded in material knowledge, manual experience, and a working rhythm transmitted across generations. Within the confined space of a small workshop, where metal is still shaped by forge, hammer, and the craftsman's patience, these traditional techniques continue to be practiced step by step. They persist not as memory or display, but as a living practice, sustained through gesture, experience, and the daily repetition of craft. Copper hammering is presented as a living craft heritage in which technique, working rhythm, and tactile knowledge are transmitted directly from one generation to the next. Through the precise coordination of hammering, annealing, soldering, and surface finishing, metal is gradually shaped by accumulated experience rather than by machines. The value of the craft therefore lies not only in the finished object, but in the very process of apprenticeship and the preservation of artisanal knowledge across generations. Thank you for staying with us until the end of this story. If you enjoyed this kind of film, please like, share, and subscribe to the channel so you don't miss any of the stories to come. Raw Machines thanks you. And until next time.